Hi guys, this is Dr. B. This is topic 5.1 reaction rates. Usually this topic is a lecture, an assignment over Christmas break. And I'm just going to, help you out with this because, it's kind of hard to just read a paper, especially over Christmas break for some reason. So hopefully you listen, you pay attention because don't forget to hit that like and subscribe. All right, so the learning objective is to explain the relationship between the rate of a chemical reaction and experimental parameters. So when we talk about rate is simply a change in something per unit of time. In chemistry, we can measure the way that substances change by looking at a change in the amount of reagents, measuring the mass, volume, moles, molarity, whatever the case may be. The unit of time is chosen based on how quickly the reaction takes place. Seconds, years, minutes, whatever the case may be. So we have this following reaction here. So we have copper plus nitric acid producing copper 2 nitrate, nitrogen monoxide gas, and water. You can measure this in different ways. Because you're producing gas, you can look at pressure change. Because you have copper 2 nitrate, you can use a spectrophotometer as it is a colored solution. You can use mass lost by the reaction. You can use the amount of nitrogen monoxide. And because nitric acid is an acid, you can actually test the pH of the solution, because as the nitric acid is being used up, your pH increases because it's becoming less acidic, it's becoming more basic. So let's look at this. So this is regarding the previous equation, reaction. So that we're going to look at the following. So the rate is the final minus initial amount, so change of amount, over change in time. Notice that the rate for reactants is negative as the amount decreases. So you have less and less reactant, therefore the amount decreases, which makes sense. The reaction rate is found by dividing the rate by the coefficient to get a value when the coefficient is 1. So let's look at this, let's look at this example here. So we have from 0 to 50 seconds, our concentration of nitric acid goes from 8 to 4 molar. From then on, your concentration of your copper 2 nitrate goes from 0 to 1.50. You can see this as a time, I'm just kind of breaking it down silly, but you can see from time as it increases, generally the rate of your reactant nitric acid decreases while the concentration, the molarity of your copper 2 nitrate increases. So how do you determine the molarity, the rate? Wow, totally off today. So from 50 seconds, let's just look at the rate of nitric acid for now at 50 seconds. So it's the final, which is 4 molar minus 8 molar divided by 50 seconds. And then your rate is negative 0.0800 molarity per second. You also see that from then your rate of copper 2 nitrate from 0 to 50, it's now 0.0300 molar per second. The rate of reaction is found by dividing the rate by the coefficient to get a value when the coefficient is 1. So for example, to get that, you would take the rate of, let's say, nitric acid, or even copper 2 nitrate, and divide it by the moles in the coefficient from the balanced reaction. That's how you get the 0.0100 molar per second. So, for example, the rate from 50 to 100 seconds in copper 2 nitrate with 0.015 molar per second, you divide it by the 3 from the balanced reaction in the previous slide, and then from there you'll get your rate of reaction 0.00500 molar per second. It's important though to recognize that the rate of reaction can only be determined experimentally. So you're going to in one of your questions on your assignment, you're going to plot a graph so you can see how the reaction changes, or how the concentration changes as the reaction goes. Okay? You should be able to plot that, with your x-axis being your time and your y-axis will be your concentration, most likely. So our last slide, collision theory. I think we talked about this, but if we didn't, cool. In order for a reaction to take place, there are three things that must happen. Particles must collide, they must have the right orientation, and they have to have an energy greater than the activation energy. So you may have heard this term before. So activation energy is the minimum quantity of energy that the reacting species or the reactants need in order to undergo a specific reaction. If you don't have enough energy for it, it ain't gonna go. Kind of like us now. Anyway, so different factors that can influence the rate of reaction. You're going to see these terms later on, so please pay attention. Reactant concentration. So if you have a higher molarity, this increases the chance of a collision just because there's more of it. If you have a higher temp, that means particles are more likely to collide because they have energy that is greater than the activation energy. So it's not really, they do move faster, but it's because they have more energy, therefore they're more likely to be more energy to surpass the activation energy. If solid particles have more surface area, so the same amount, but there is maybe there's the same amount, but maybe there's smaller particles, they're broken down more, then there's a greater chance of particles colliding. Basically, there's more areas for a reaction to occur. And the last one is catalysts. So catalyst is something that is used to speed up a reaction. There are two different types: homogeneous and heterogeneous. A homogeneous catalyst is one where they're in the same phase. And what happens, like let's say for example you have something that's aqueous, it's placed in aqueous, or it's gas, placed in a gas. And it speeds up reactions by providing an alternate pathway to complete the reaction, therefore there's less activation energy. If you have a heterogeneous catalyst, so they're different type of phases, I'm just highlighting everything now, like a solid and an aqueous solution, it speeds up by altering the orientation of the molecules so that the correct sides of the reactants can collide. So there's more effective collision. So there are different effects based on what you're using. So if you have a homogeneous, I'll use a pencil. If you have a homogeneous catalyst, alternate pathway, to affect or to lower the activation energy. If you use a heterogeneous catalyst, you're altering the orientation, so more effective collision. So you can probably almost bet, maybe, if you're a betting person, which I don't recommend, that you would have something like this type of question, where they're going to make sure that you know what type of catalysts there are and how they would tell you the different type of catalysts, and they maybe would say, so how would this actually how would this impact the rate of reaction? So make sure you read these, review those. If you have any questions, please let me know. Thanks. Hit that like and subscribe. Thanks. Bye.